Today we're going to be reviewing a lot of the network elements that are required to model signalized intersections. So this is going to include objects such as signal controllers, signal heads, and detectors. And then we're also going to look at the setup that's required to model both permissive left turn and then also right turn on red. So signalized intersections within Vissim are going to be comprised of an overall signal controller. And then once that signal controller has been defined, we can then further define the network objects for that particular intersection. So all of the signal heads in the network will be placed at the stop bar locations, and those are going to show up as this red bar on the link itself. And then detectors, which can be used to track the presence of the vehicles in the network, will be added as this blue box. And then any right turn on red movements will be modeled with stop signs. And so those are going to show up here as these orange lines on the links or connectors. And then finally, for any of the permissive turns, such as like the permissive left turns, or if we have these right turn on reds, in order to model those conflict areas, we'll have to actually add in those conflict areas within the network so that the vehicles will be able to see each other on those conflicting movements. So again, before we get started to add any of the network objects like those signal heads or detectors, first we're going to need to add the actual signal controller that's going to contain all of the signal timing data. So in order to open up this signal controller list, first you'll just go to the signal control menu item at the top, and then you can choose the signal controllers option. And this will open up a signal controller window down at the bottom of the screen. And in here you can press that green plus button, and that's going to open up the signal controller window here, which we can further define that particular signal controller element. And then once those controllers are added, those will just show up here in this list. So then you can further edit them or just view them later on. So within the signal controller window, this is where we can define the signal controller number and then the name, as well as the type. So there's quite a few options built into Vissim that can be used for different controllers. So there's like fixed time controllers, ring barrier controllers or RBCs. And then there's also some built-in controllers such as the two-stage controller, a pedestrian controller, and a railway crossing controller. So the RBC, or that ring barrier controller, is the default signal controller in North America. So that's going to be the controller that we'll be looking at today in more detail. So then once you have that type set up here, so in this case we've got that ring barrier controller set up at the top, you can then actually start to create this file. And this, for the ring barrier controllers, these will be saved as an external data file. So you'll see these once we add them into the model, that these will show up as a separate file with a .rbc extension. And so in order to add this file and start adding in our signal timing data, down here in the middle under this controller configuration tab, you can select this edit signal groups button. And once you select that, that's going to open up this RBC editor window on top of that signal controller window. And this window itself consists of four main parts. So the first is up here at the top, which is just the main menu bar. And this, like most other menus, will allow you to either save this external file or import. If you already have some existing RBC controller files, you can import those as well. And then you can also change the window setup underneath that view drop-down menu. And then over on the left-hand side, we have the selection panel. And this will allow you to open up different data tables. And all of these tables are going to show up in this window, this larger window here on the right. And so again, this will just display all of the different signal timing tables and all that data once you have some of these options checked over here in the selection panel. And then finally, down at the bottom, we have the timing display, which you can't see right now because there's no data within this particular window. But once we start adding data, you'll be able to see that signal timing show up down here. And then below that is where we have different logs, so you can see any particular messages or warnings or errors when you're building your signal controller. So once you are creating a new RVC controller, when you're opening this up initially, the selection panel is all going to be unchecked. And you'll notice at first there's nothing over here within this data table. So in order to open up some commonly used signal timing parameters, you can go up to the View button up here and then just select this basic view. And this is going to load this default layout, which contains a lot of the parameters that are necessary when you're building up your RVC controller. And so once you have this view loaded, then you can just quickly get to work and start adding in a lot of that signal timing data. So the next portion here, we're going to kind of go over all of these parameters within this default layout in a lot more detail. So we're going to take a deep dive within a lot of these parameters, but we'll also show you too where there are some additional resources where you can go after this training as well, where you can get a more detailed explanation for these parameters as well as all of the other parameters within this controller window. So at the basic section up here at the top, the very first thing we'll need to do is define these signal group numbers. And if you already have a signal timing plan provided that you're trying to input into Vissim, it's recommended that you just stay consistent with that provided plan and just use those same numbers. Otherwise, if you don't have a signal timing plan, you can use the standard NEMA phase numbering and just add in those numbers up here within that signal group number. And these will need to be defined first before we start adding in any additional data. So then once we have that, then you can add in a signal group name, such as like northbound left, southbound, eastbound left, etc. And this is especially helpful, particularly down here in the signal timing display, which we'll talk a bit more about later. But you'll see here that in addition to those signal group numbers that display, that signal group name also shows up. So this can just be a quick reference when you're opening up the signal timing plan and reviewing that information. And then directly below that is where you can enter in any minimum green time that that signal group will need to serve before it changes to yellow, as well as a vehicle extension time, which will be that allowed time between vehicle calls before that signal group will gap out. And then below that, we have the next one parameter, which will define that maximum screen time that that signal group will be allowed to extend before it's going to actually max out and move on to the next phase. And then below that, we have the yellow time that will just be that amount of yellow time that signal group will show before it advances to red. And then we also have that red clearance time, which will define, again, that amount of red time before that next conflicting signal group will be allowed to begin timing. So these are kind of the big main base parameters that we'll need to set up. And then directly below that, we have some different parameters here for the pedestrian. So first, you'll have to define that pedestrian signal group parameter, which will just be used for any of those pedestrian movements. And then below that, you can define the walk parameter, which will just show you the minimum amount of time that signal group will display that walk indicator before it advances to the pedestrian clearance interval. So directly below that is where you can define that pedestrian clearance time. And this one will just show the amount of time that a flashing don't walk sign will be showing before it advances to that solid don't walk. So these here are just that main pedestrian signal group parameters that you'll need to add if you are modeling some pedestrian movements at your signalized intersection. And then below that, we kind of have a group of different checkboxes. So the first one here is the startup parameter, which will be checked for any signal groups that are going to be green at the start of the simulation. So in this case, 1 and 5. And then below that, we have the minimum recall option. And so if this is checked for a signal group, then that signal group will receive an automatic vehicle call whenever they're not green. And then we also have that maximum recall option, which in this case, that signal group will receive an automatic vehicle call and extension. And then the last of the recall options here is for the pedestrians. And so if that pedestrian signal group receives an automatic pedestrian call as well when this is checked when they are not in walk. And then finally, to wrap up the basic section here, we have that dual entry parameter. And so this is going to be most often used for the through movement signal groups, so that if one of them ends up getting called, then that signal group in the opposite direction will also be automatically served, even if that one doesn't have a particular call. All right, so then the next section here includes different parameters for patterns that can be used. And you'll see here, if you did scroll down within the selection panel here, there's an option for 8 different patterns that you can set up within a particular RBC controller. So the 2 main values here that you're going to need to set for the pattern, especially if you're modeling coordinated signals, is going to be the split value. And so the split here is going to represent that amount of time that will be allocated for that signal group to time. So this will include the green time, the yellow time, and the all red intervals. And that should be at least equal to that signal group minimum green time that's been set up here at the top, plus that yellow time, and then that red clearance time. And what's also important is that the sum of all of these splits within each ring should also add up to the cycle length that is set for that particular pattern. And then in order to model any signal coordination, there's going to need to be a coordinated signal group selected. So in this case, if this is not checked and you are running a pattern for this particular controller, then this controller will just be in free running mode. So in this case, it is important if you're especially modeling coordinated signals that you just go ahead in here and check what those coordinated signal groups should be. Okay, and then so directly below this, we have the schedule. And so this will allow you to select the pattern number that will be used when the simulation is running. And in here, you can also select the free running option, as well as any of those 8 different patterns that have been set up. And then directly beside that is also the pattern start time. And so this will be the start time in simulation seconds that that pattern is going to get called. And so this can be used if you do need to change plans during a simulation run. Typically, a lot of the time, it will just be a single pattern for that run. But if you are modeling, especially multiple hours of the day, and you need to go ahead and change plans in the middle of the run, you can just add in additional line items here and just change that pattern start time, which will need to be in simulation seconds. So if you needed it to change an hour into the simulation, you can just type in 3600 here, and then that's going to go ahead and switch to the next pattern. And then directly below that, we have the sequence editor. And so this will allow you to add in the signal group sequence for this controller. And again, first, those signal groups up in the basic tab will need to be defined before you can enter in these numbers within here. And a signal group must be included in the sequence in order for it to time. So if we did leave out like 4 and 8 in this case, then those signal groups will be ignored in the controller as it's running within the simulation. So as you're entering in these, you'll also see that we do have a barrier put in place here. And so in order to add any of those barriers, you just kind of hover on that column header, and there'll be a little plus minus button that shows up as you're hovering here. And if you click that column header, that will create this barrier to the right in the column right below it. Okay, and then below that we have that overlap section. So this will allow you to define any overlaps so that if you had an overlap signal group, that will remain green while the parent signal groups are timing one after the other. And then below that we have a section here. If you need to model any actuated signal control, then we can set up the detector information within this section. So in here you can set the detector number that's going to be used to call or extend a particular signal group. And so for these, it's recommended that you use that same number as the corresponding signal group, just so that it's a bit easier to keep track of and to code when you're adding in the network objects. So once you have that number added, you can then add in the call number. And so this will just be that signal group number that will be called when that detector input is on. And then you can also set the signal groups that should be extended when that detector input is on as well. And then similarly for pedestrians, you can also add in the pedestrian detectors and those pedestrian signal groups that should be called once that input is on. Okay, and then finally in the lower left area of that selection panel, this contains some more details for the patterns, particularly the cycle length and the offset, which you can set over here. And by default, when you open up any of these controllers, it's going to just default here to pattern 1. But if you do want to switch this, you can press this little plus icon over here in the corner, and this will allow you to change either to the free running timing or one of the different other patterns in here. And then once you have that pattern selected, then you can go in here and update any of these parameters. And then also, depending on that selection, that will show up the corresponding signal timing plan down here at the bottom as well. And what's also nice is once you have some of those basic parameters added, you can also quickly edit any of these signal timings. So for example, if we are editing pattern 1 split values, you can actually just click and drag these bars in here, and that will automatically update those split values up above within this data window here. All right, so that is kind of a deep dive into all of the basic view parameters, at least for the RBC controller. So once you have everything set, you can then click OK down here at the bottom, and that's going to save the signal timing plan. Again, it will show up as an external RBC file, and so it's recommended that you do save these just in the same folder as your Vissim network. That way everything's kind of contained in the same area and can keep all of those references intact. Okay, so now that we finally have all of our controller data set up, we can now move on to defining a lot of those relevant network objects that we need for our signalized intersection. So first up, we're going to talk about the signal heads. And like in the field, these are going to force vehicles to decelerate to a standstill condition when they do show red. And then once that signal turns green, if the vehicle is stopped, it can then accelerate back to its desired speed. And within Vissim, these signal heads are going to work both as a signal head in the field and also as a stop bar. So it's important within the simulation that you actually place the signal head location on the stop bar itself and not where that actual signal head is showing up in the field. So you'll just want to make sure when you're adding these in that you just place those on that stop bar location. So in order to add a signal head, first you'll just need to select that signal head object from the network object toolbar. And then you can either right-click on a link to open up that context menu and select Add New Signal Head, or you can also just press Control and right-click, and that will automatically place that signal head at that location on the link for you. And especially when you're adding in these signal heads and you need to find that stop bar location, it can also be useful to turn on that background imagery. And then you can also switch to the wireframe mode so that you can see that stop bar location in more detail. Again, using that, the wireframe mode can be turned on using that Control and A at the same time. So once we have that signal head added, then the signal head window will open up and display. And this will allow you to set the number for the signal head as well as the name up here at the top. And then it'll also show that location, so you can see the link and the lane number as well as the position up here. And right here underneath is going to be one of the big parameters here for the signal head, so this SD-signal group. And what this means is the signal controller number and the corresponding signal group number that will need to be used and what the signal head should be connected to. And then you can also add in a secondary signal group as well if you want or need that to be connected within this OR signal group. And if that's added, what will happen when both of these are in play, that the signal head will also display green when either this primary signal group is green or that secondary signal group is green. And this OR signal group, which we'll also talk a bit more about later, is going to be particularly useful if you are modeling any protected permissive left turns. So that way you can add in the left turn up here in the main signal group, and then you can add in that through phase down here in that OR signal group section. And then you can also set up a type as well. This is going to just default to circular, but you can also change it to a left arrow or a right arrow if you want to. And this will really just change the signal head display when the simulation is running. So if you do change this to a left or right arrow, the signal bar will just show up with a little arrowhead on it. And then down at the very bottom is where you can change the different vehicle classes that are going to obey that particular signal head. So if a vehicle should ignore the display, you can uncheck this all vehicle types option over here, and then you can go ahead and check the desired vehicle classes over here on the right. All right, so now moving on from the signal heads over to the detectors. So if you have any actuated signals, then we will need to go ahead and add in those detector objects for that particular intersection. So detectors within Vissim work pretty similar to those in the field. So as soon as the front of the vehicle crosses the detector, a detection signal is going to get sent back to that controller. And then as soon as the rear of that vehicle leaves the detector, that detection signal is going to change to no detection. So for the Vissim detectors, these should be placed really at wherever that calibrated detection zone is in the field. So for example, if you do have induction loops in the field, then you'll just want to place those detectors in that same physical location for that same length. Or if you have video cameras, you'll just want to place those detectors over that same area where that camera is going to actually recognize those vehicles. And then for any pedestrians, if you want to add in like a push button detector, then you can just place a small detector on the ground wherever that pedestrian is going to stand and actually push that button. So in order to add that detector into the network, first you'll just need to go back to that Network Objects toolbar and click on that detector object. And then you can either right-click on the link and then select that Add New Detector option over here in the context menu. Or instead, you can also press Control, and then if you right-click and drag, that will create a detector of a desired length. And then once you have that detector added, this detector window is going to open up so that you can further define some of those settings. And up here at the top, so the big important attribute here up here is this port number. And so this is going to tell Vissim which signal controller signal group number that detector should be connected to. So again, just based on how we set that up within that signal controller window. So in the vehicle detector section, we set up the detector number as well as the corresponding signal group to call. So you'll just want to make sure that you put in that detector number here within that port number. So again, this can just be a bit easier to model and just keep track of things if you do keep those detector numbers matching to that corresponding signal group number. And then you can also choose that particular signal controller that the detector is going to connect to. So this is kind of the signal controller number that we'll need for that detector. And then you can also define the length of the detector over here on the left-hand side. So when you're adding in these detectors, if you use the context menu, it will just place a detector of a default length. Or again, you can use that control and right-click and drag to define your length for you. But you can come in here and further refine that if you have a specific length you want to enter in for that detector. And then finally, up here at the top, we have this type option. And this is going to default to standard, but you can also update it to a few other options such as pulse, presence, or a PT calling point for any public transit. But for most of the standard applications used for signalized intersection modeling, this standard option will suffice for those. And then at the bottom, you can also further refine any of that detector location, so the lane number and then the location on that lane. Or you can also enter in this before stop attribute. And this will show up if you have a signal head and detector on the same link or connector. And so this will be the distance before that signal head, where that signal head is placed, where you want that detector to show up. So this can be useful if you just need to enter in a predefined values. If you know in the field that your detectors are a certain distance upstream of that signal head, you can use this attribute to add that in to your network. And then over here on the activation tab for detectors, you can select which vehicle classes should be recognized by the detector. So by default, it's going to set to all vehicle types. But if you want your detector to only detect certain vehicle classes, such as public transit or maybe heavy vehicles, you can just come in here and change that selection by pressing Control, and you can highlight multiple options down here for any vehicles that should be taken into account and recognized by that detector. All right, so that goes over all of the big required objects for standard signalized intersection modeling. So in this section, we're going to take a look at some of the required setup for all of the permissive turns. So first, we're going to start with any of the permissive left turns in the network. So for if you have a permissive only left turn, within that signal head window, you can just enter in that through phase up here in the regular signal controller primary signal group dropdown. However, if you are modeling a protected permissive left turn, then you're going to want to enter in that left turn phase up here within the signal controller dropdown, and then enter in that through phase down here within this OR signal group. So just depending on what type of left turn you're modeling, you'll just want to make sure you've got both the primary and the secondary ones set appropriately. And then for either of these permissive left turns, either if it's completely permissive or just permissive only, or if it's protected permissive, you are also going to need to add in a conflict area in order to manage the conflicts for these vehicles and have them yield appropriately. So in this case, you can see here we've got a conflict area added for this northbound left turn. So in this case, it will allow the set priority to the southbound through movement and have those left turning vehicles wait until this area is clear before proceeding. So I also wanted to note that the conflict areas won't need to be added if you have just all protected movements within your intersection, because all of those vehicles are going to be controlled by the signal heads themselves. so those vehicles will not come into conflict with each other. So really, these conflict areas are just going to need to be added for any of these permissive turns within your intersection. So the second permissive movement here is for right turn on red. And so this kind of requires a few different objects that we'll need to set up. So within Vissim, the right turn on red is actually going to be configured using a stop sign here, which is showing up as this orange bar. And what this will do is actually allow vehicles to come to a complete stop when a particular signal group is red. And then it will allow it to check for any conflicting traffic. And once everything is clear, it can then continue on its path. So in addition to this stop sign, which will be hooked up to a particular signal group, we can also still add in a signal head just for display purposes. So this will just kind of be a visual display so that we can be alerted whenever that particular signal group is green or red, which can just make it a bit easier when you're viewing the model and also just debugging the model as well. And then finally, like the permissive left turn movements, we will also need to add in another conflict area here too for any of the merging conflicts, just so that the vehicles that are making this right turn on red will be able to stop and wait and make sure that they have clearance before they can continue on their journey. Okay, so here is a slightly different configuration for right turn on red that just wanted to bring up. So in a lot of the examples we've looked at so far, the signal heads have been placed on the connectors. So you can see here we've got the signal heads themselves just placed on the connector rather than on the link. However, in some cases, just depending on how the network is being built and like where that stop bar location is, sometimes this may end up being on the link instead of a connector, which is completely fine. You're free to model any of these signal heads on either links or connectors, just really just depending on kind of where that stop bar location ends up being. But if you are modeling a signal head on the link itself, and also happen to have a shared right turn lane with a through lane, like in this case, we've got our right turn connector and then our through connector here. In this case, we'll just need to be a bit more careful about how we place the connectors themselves. So in this case, again, we have our main link with the main signal head placed here on the link itself. And then we also have for our right turn, we have our stop sign and then our right turn signal head for display purposes here. And then in this case, since this is a shared movement, you'll want to make sure that for this right turn connector, that the start point of that connector is placed just upstream of this through movement signal head. And what's going to happen in this case is that any of the right turn vehicles, when they're traveling here, they're going to jump onto this connector and they will avoid this through signal head here. So they'll jump on this connector and then they'll be able to see their right turn signal head and right turn stop sign. Otherwise, what can happen if this connector is placed downstream of the through signal head is that those vehicles making a right turn are actually going to hit the signal head first. And so if this signal head ends up being red, all of those right turn vehicles will get stuck by the signal head when it's red and won't actually be able to continue on to their right turn connector. So those vehicles will actually never end up getting to make that right turn on red movement. So again, this is just for this very specific case where you have a shared right turn lane and you also have those signal heads on the links themselves rather than having individual signal heads on the connectors. So if you don't want to model things in this way, you can also keep that connector down here at the end of the link. And then in that case, you'll just want to move that through signal head to the through connector. And this will just make sure that the vehicles traveling in either direction will be able to see their corresponding network elements and won't get stuck using both or one over the other. So, and then a little bit more configuration is needed in order to set up all these right turn on red settings. So within the stop sign itself, when you have that added into the network, there's this right turn on red tab here. And this will allow you to set the connected signal controller and signal group number. And this will typically be that signal group for that concurrent through movement when you're setting this up for the right turn on red stop sign. And then on the signal head side, the big difference here is that since we're only using this right turn on red signal head for display purposes, you'll just want to uncheck all of the vehicle classes and down here at the bottom. So that way that they will be able to ignore the signal head since it is just for display purposes, and all of their movements are going to be controlled by the stop sign instead. Okay, and then finally, also just wanted to show you an option for viewing some of these signal and detector states while the simulation is running. So of course, when the simulation is running, the signal heads themselves will show up as different colors so you can quickly and easily see the green, red, and yellow states. But if you do want to see these in more detail, you can use this option called a signal times table. And this is particularly useful when you're either debugging a model or if you are just wanting to verify that the signal is timing appropriately. So in order to bring up the signal times table, you'll want to return back to that signal controller window. And once that's open down at the bottom, you can right-click on any of those signal controllers, and then you can go to this option here where it says Show Signal Times Table. And once you have that option selected, this is going to bring up a new window here, and it will show you the signal controller numbers. So in this case, we're here for signal controller number 1. And it'll also just show you that this is the signal times table. And within this window, it's kind of broken up into 2 sections. We have the signal groups up here at the top, and then the detectors down here at the bottom. And so for this top portion, we're going to get to see all of the signal group times. So we can see the green times here, as well as the yellow times. And then you'll also see we'll also have some blank areas here, which are just going to show the red clearance time before that next signal group starts timing. And then also on these, since we are running a pattern in this case, you'll see here that we have some of the start time for that particular signal group, as well as the end time. And the time bar as well will show up down here at the bottom. And you can also see, since we are running, in this case, this was 120-second cycle length, so you can see once we hit 120 seconds, it will go back to 0. So this will just allow you to quickly see how those times are being shown and calculated within the simulation. And then down at the bottom, we have the detector occupancy states. So in this case, you'll see here in the blue that shows up. This will show up whenever a vehicle is located on a detector. So again, this can just be a really useful tool if you're reviewing a model or reviewing a network and you just want to verify that the signal timing is timing properly. And this will also allow you to see if your detectors are being occupied correctly, and just make sure you've got your detector numbers tied up to the right signal group numbers, and just make sure that everything is hooked up and running appropriately. So from here, we can go ahead and take a look at our example file. So within our network here, we have 3 different signalized intersections that we've started to add in. So again, if we go up to the signal control tab and then click on signal controllers, this will bring up that overall list of all the different controllers within the network itself. And you can either edit these, again, if you double click on these, you'll be able to see that main controller window, and then you can click on edit signal groups to open up, in this case, that RBC editor window. What you can also do as well is if you're in the signal controller window, you can also right click and then just go to edit signal groups, and that will bring up this RBC editor window for you directly. And so again, once you're in here, you'll see by default some of this stuff is kind of unchecked. So if you do want to open up that default layout, you can just go to View and then Basic View, and that will open up a lot of all those tables that we just went over. And you can see here that there are some other options as well that we didn't cover today, but you can see there's some more like an advanced section, and then there's also all of these different patterns as well. So if you do have different patterns for different time of days, you can go in here and code in different timings for each of these as well. So in this case, when you are opening up a controller, you'll see here as well, the pattern 1 ends up showing up here on the left-hand side. And what I'll do is I'll just scroll down here, and you can actually see in the schedule for this particular intersection, this is a free running signal. So if we want to switch and have that timing show up down here at the bottom, if you right click on this pattern 1 here, you can then go down to free running. And this will update the signal timing display down here at the bottom. And what's also nice about the signal timing display, again, you'll see the signal group number and the name, but you can also change the timing directly within this window. So this can be sometimes a bit easier to configure rather than coming in here and entering in values for like the maximum green time when you're looking at the free running signal, or for the splits if you're looking at a different pattern. So once you're in here, if you want to, you can just left click and drag, and that will allow you to change these timings. And you'll see while we're changing these that these max screen times are actually going to update for us. So you'll see here we can just kind of quickly change the signal timing. And then likewise for pattern, if you did have a pattern set up, you can do the same thing here, and you'll just see here that that split number is going to change depending on which pattern you have selected. So in here we also have, again, that sequence defined here. And if you do need to change this or add in any additional barriers, you'll notice again to add in those barriers that when you're hovering in this top column header, there'll be a little plus minus that shows up. So you can just double click here, and that will add in one of these barrier groups. And you can also just double click again to remove those. And you'll also see down here in the signal timing display, these will show up as a blue line as well down here in the bottom. So you can just quickly see where those barriers fall in here. And then also in here we have some of the detector information set up. So we have here our detector numbers with their corresponding signal group that they will call, as well as the signal group that should be extended. And then again, once you have everything saved, you can hit OK, and you will continue from here. So the other thing that I wanted to bring up is that once you do have these controllers saved, they will by default just show up here in within the same system directory. So here we've got our file, and then you'll start to see some of these RBC files will just be contained externally. So if you notice, or if you need to import or save any other files, we do recommend just to keep them all together. That way it's easier for the references and just to make sure that all the files and information can get loaded properly within the Vissim network. Okay, and then so in this model we have intersection or signal controller number 1 up here, and then this one down here is for number 2, and then we have number 3 over here. So for number 3, I just wanted to go through and add in a couple other of these signal heads and detectors. So another useful feature when you are modeling and adding in a lot of these signalized intersection control elements is you can turn on some of these labels, which is especially helpful for the detectors and the signal heads in this case. So if you go over to the network object toolbar, you can turn on the labels by just hovering over here next to that particular object, and you'll see a little A with a slash through it. And you can turn those labels on by just selecting that. And by default, the detectors themselves, if we click on the box next to it to see the graphic parameters, the detectors are going to show the port number. So we can just quickly see kind of what port number we're using, which we have tied to that corresponding signal group number. And then on the signal head side, right now it's actually just showing the signal head number. But what we can also do is click that there, and we can actually change this to the signal group number, just so that we can quickly see what controller we're using and what the signal groups are. So this will allow you to just quickly see, again, that signal controller is that first number, and then the signal group number is the second number after the dash. So here you can see we've got signal controller number 2 over here on the left, and then we have signal controller number 3 over here on the right-hand side. And again, for adding in these signal heads, I'll go ahead and turn on that background imagery by turning on the globe icon. And then I'm going to go ahead and switch to wireframe mode. You can either do that again by clicking the wireframe button, or you can just press Control A. And this will just allow you to see those stop bars a little bit easier when you're in the wireframe mode. So in this case, first I'll go ahead and add in the signal head here. So I'll just make sure I've got that selected, and then I'll just press Control and right click to add in that signal head. And then in this case, we'll want this signal head to be for controller number 3 and then signal group number 6. And then I'll just hit OK. Since this is just a through movement, we won't need to add any information in the secondary signal group here. And then once I have that one added, another useful tip here when you're adding in a lot of different signal heads is that you can just press Control C and Control V to copy these objects into another lane. And you'll see here, if you are copying either a signal head or a detector, you'll see this window will pop up asking if you want to copy the signal controller. In this case, we still want everything to reference controller number 3. So we'll just hit this Don't Copy Signal Controller. And so what this will do is just make sure everything stays in references that same signal controller number 3. And then if we go ahead and put in the detectors here, I'll just change to the detector object. And then again, you can either right click and click Add New Detector, which will just drop in a detector a little bit shorter than 10 feet. Or you can also just press Control and then right click and drag, and then you can add in a detector with a particular length. And you can also see here that the length and some of the lane information will just show up here in the tooltip. And once you have that added, you'll just release all of those buttons, and then you can go in here and further refine the length if you want to. And then you'll also want to change the port number, which in this case, since we're doing signal group number 6, we'll change that to port number 6 since we have those mapped up to the same number. And then I'll change that signal controller number to number 3. And then I'll click OK. And then again, for this case, I'll just press Control C and Control V to drop in another detector. And again, I'll just not copy that. That way that won't copy any of those references to a new controller. Okay, so now we have all of those added in. And within some of these intersections, we have, in this case, we just have a permissive left turn set up on both the east and west directions. So you'll see here we just have that through signal group set up here for the primary signal group. There are some of the other intersections, like in this case for intersection number 2, we have this eastbound left set up here to just have a protective left only phase. So in this case, you just have this set to that left turn. And then up here at the top, we have a protected permissive left turn. So in this case, we've got the left turn phase set up in the primary phase, and then we have that through movement, in this case number 6, for the OR signal group. So that way the signal head will time green whenever signal group 1 is green or signal group 6 is green. And again, in this case, since we are doing a permissive turn, we have our conflict areas set up, so that way the vehicles, we can control those conflicting movements and make sure that we give priority to the through movements and have those left turn vehicles wait until that area is clear. And likewise for the right turns, we also have these conflict areas set up as well. And then for the right turns, we do have some of those right turn on red set up. So in this case, we have all of the signal heads placed on the connectors, so that way we can leave the connector locations as is. And so here you'll see we have, in this case, the eastbound left is set up on its own connector, and then we've got our eastbound right here. And again, for the right turn on red, we have this signal head turned off for all vehicles, since we're just mainly using this for display purposes. And then we have our stop sign here configured for right turn on red, so that it's going to be connected to this particular signal group. And in this case, we have signal group number 9 set up here because this is an overlap phase that we set up within the signal controller. Okay, so from here, let's go ahead and just run the simulation, and we can see how these behave. And whenever you are starting the simulation, you'll see at the bottom here that it is going to go through and initialize each of these controller files. Just because they are an external file, it has to go through some initialization. So once that's complete, then the simulation will start running. And I'll go ahead and turn off some of these labels, and that will help speed up some of the simulation. And let me just move along a bit here. So here you can see we've got some of our signal heads are timing. Down here we have configured this particular signal head to have that type left arrow. So you'll see that one actually shows up with the left arrow display while it's running. And then you'll also see here that for the right turn on red, any of these signal heads will just show up that display, but the vehicles will obey that right turn on red that's been set up for that stop sign. And then for any of those permissive movements, those vehicles will have to yield because we have all of our conflict areas set up appropriately, so that way they will just avoid any of those conflict zones. And then finally, I'll just go back to that signal controller window. And if you do want to see any of these, again, in more detail, you can right-click on any of these controllers while the simulation is running and go to Show Signal Times Table. And let me just expand this a bit here. And this is for our intersection number 3 that we just finished up. So this will allow you to see the green time, again, that yellow time, and then some of that red clearance time as well. And you can also, if you click on any of these items and then just click and drag, you'll also see here in the lower left corner, a little box will show up, which will allow you to also measure the amount of time. So if you just wanted to quickly see what some of these green times or green plus yellow times are timing out to be, you can just left click and drag just to quickly measure some of those times while the simulation is running. Okay, and with that, that should wrap up our discussion on signalized intersection control.